Hey friend, welcome to my lecture. So today we will speak about bitrate, bandwidth, and latency. This is important concept, so we'll go step by step, and we will solve some kind of problems together. So maybe some question will be there. We'll start with the bitrate. But before bitrate, just we'll talk a little bit about information of these three topics. All of the computing devices on the internet are communicating in binary, whether they are connected via wired or wireless. They are sending electromagnetic signals that represent streams of ones and zeros. Let's explore how those bits are sent and how quickly they can be sent. Okay, we can. So I want to explain something before go to the another topic, but so also we'll look for the sending streams. Anyway, what is that? Just we can hide it. Um, Before go to sending streams of ones and zeros, I want to speak about what is this communication between wireless and computers. In computer, we have Wi-Fi cards, wireless cards. Okay, this wireless cards sending some electromagnetic signals, and wireless cards also sending there some electromagnetic signals, and they are just communicating with the bits. Okay, with the bits, with the digital binary numbers. Okay, so it's just converting to digital data. It's like it's coming like one and zeros. Anyway, we have some way with the electric, with the fiber cable, fiber optic cable, and the communication can be with the Wi-Fi card, which is radio signals. Anyway, let's go to the sending streams one and zeros, ones and zeros. Let's come slowly to down. Okay. When computers need to internally represent the number 5, and so 101, which is, we can say the 1 will be 1, 0 will be for 2. I mean, 1 power of 0 and 2 power of 0 will be 4 and 5. Anyway, this is already I told before. And okay, this is 5. They can use 3 wires to represent the 3 bits, which is, we know, right? We have 3 bits here, and one wire on, one wire off, one wire on again. So 1 0 1 on, off, on, like that. It will send 3 wires, but let's come with the details. So it's like that. Okay, if a computers want to send the number 15555, but I think it will be 5. Okay, maybe we can make it like 5, and this one 5, right? If a computer wants to send the number 5 to another computer, they can't use as many wires as they want. Yeah, just don't think like 5, so 3 point will be go like that. It's not like that. So there will be some waiting. Okay, waiting, like on, off will be waiting, then again on will be 1. I mean, 1 0 will be waiting, and 1 again will be continuous. Okay, anyway, where is it, right? In fact, they may only have a single wire to send information, or instead they can send a number 5 or 3 time periods. First sending and on pulse and waiting, then sending nothing and waiting, then sending on pulse. Okay, this is some way I told you, like that. So let's come here. Okay, first it's sending and waiting here, like 0, and again 1 is sending, so it's continuous. Okay, this is some way like that. We control it. Okay, let's come here. Yes, to here. As long as the two computers agree on the time period. So just think, one computer here, one computer is here, and they're just sending, but with the control. Okay, with the time period. Just think, it's sending. Maybe it can send, like, just say 6. Okay, number 6. It will be what, like, first place will be 0, another place will be 1, another place will be 1, like 0, like waiting, and continue like that. It will take 5, just, it will take 6, and just think another computer want to send him like 8. What it will do, like, it will send there 4, it will send there 1 8, and another ones will be 0. Like what? 0001. Okay, it will send wait, 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 and it will send 1. Like it will be 8 here, which is you can see like sent this one. It's going there, received 101, and it wants to send 110. It's going 0, which is this 2, which is this is 4. Like you can see, right? And it's sending there to back. Well, the position is changing. Anyway, let's come down. I think you got it. I need to slowly. I need to go slowly. Right. Okay, here. In an electrical connection, just such as Ethernet, Ethernet, the signal would be a voltage or current. Okay, voltage will be. So in an optical connection, such as fiber optic cable, which is a new technology in the world, like, but it's still improvement coming there. Anyway, the signal will be the intensity of light. Yep. The process of turning binary into a time. The process of turning binary data into a time-based signal is known as line coding. Okay. There are various line coding schemes that can be used based on the needs of the connection. Okay. Yes, guys. Now we'll speak about bit rate. Okay, let's go a little down to the here. Network connections can send bits very fast. Okay. We measure that speed using the bit rate. The number of bits of data that are sent each second. Okay. The earliest internet connections were just 75 bits per second, which is very, very little. These days, connections are more than often measured in megabits per second. So it's 1 megabits per second. It's 1,000 kilobits per second, and 1,000 kilobits per second. It will be like 1 million bits per second. Anyway, 10 I think it's 10. We're coming. I don't understand that. Okay, 10 megabit is huge, like 1 million bits, I told you. So, a 10 megabit per second connections transfer data 10 million bits per second. A megabit is just 1 million bits. It's 10 million bits is just 10 megabit per second. Okay, in a minute, so in a second, sorry, not minute, in a second, we're sending one 1 million bits. Okay, you can think like that. 1 million bits with the 1 megabits per second. So 1 million bits information. I told you five. We're sending five. Five is just 3 bits. Like, just think how many data we're sending in the same time. Anyway, that's 1 bit every 100 nanoseconds. 1 bit every 100 nanoseconds is just 0.0000 second. It's so very big, right? It's like that. Second and it's sending 0 and again 1. It's crazy. I'm sending all like that. We also measure bit rate in the smaller units like kilobits, 1,000 bits, or much bigger units like gigabits, 1 billion bits. Yeah, and even petabits at 1 quadrillion bits. Also, petabits. We have our storage in our brain is three petabits. Okay, you can learn also it with me. This is good information for you for maybe daily information. Okay, yeah. Let's come down. Let's look here. Yeah, the here. Uh, no, little down. Yeah, we can check here now. Unit, number of bits, kilobit, megabit, gigabit, terabit, petabit. Kilobit is just, I told you, 1,000 bit. 1,000 bit is just a 1 kilobit. So 1,000 kilobit is just 1 megabit, and 1,000 megabit is just 1 gigabit. Uh, Also, you can see there about bits, okay? But I'm talking about process of the time. Anyway, the 1 terabit will be 1,000 gigabit, and 1 petabit will be 1,000 terabit. Anyway, no, yeah. It's just you can think like that, okay? And you can see the about bits, how much bits it's totally, okay? Just look, 1 petabit. If you send in a second 1 petabit, it will be 1 quadrillion bits. This is very big information, guys. So it will be very fast if you are downloading or if you are uploading it. Now let's speak about bandwidth. We use the term bandwidth to describe the maximum bit rate of a system. Ah, if a network connection has a bandwidth of 100 megabit per second, which is like it will be how much? It will be 100,000 kilobits and many more bits. Anyway, that's later we can calculate it. 100 megabits per second. Fortunately, that's still a lot. Okay. Ever heard of term broadband internet? That refers to a connection with a maximum bandwidth of 256 kilobit per second. That's enough bandwidth for basic internet use like checking emails and reading websites, but not quite enough for watching online videos. As of 2016, only 40% of people in developing nations have access to even broadband internet. Right, like that. Check your understanding. Let's check your understanding with me. Okay. Where is our pencil? Okay. It can be maybe green. Okay. When I was kid, our internet connection had a bandwidth 56 kilobit per second. How many bits per second could be transferred? So what do you think? 1 kilobits per second, it will be 1,000 bits. And 1,000 bits, if we can say 56,000 bits. This is that. Okay. It will be 5.6 kilobits. It will be zero point 0.5 kilobits. And this one will be more crazy than it, like 560 crazy things. Like, let's come down. Latency. This is very important topic, guys. Another way to measure the speed of a computer network is latency. You might guess what that means from the word itself. Latency measures how late the bits arrive. To put in a more formal terms, latency is the time between the sending of data message and receiving of that message measured in the milliseconds. Okay, we typically measure the round trip latency of. I can change this 1 minute. We typically measure the round trip latency of a request. Let's walk through a real example to see what that happens. Okay, let's guys come down. Now, first, just think you're writing their ping www.google.com. In 30 milliseconds, you're going to do there. Okay, it's round trip starting here, and from the data database or data center, this message coming back to your computer 40 millisecond later. So there is 10 millisecond latency here. It can change situation of the computer networks between computers, maybe differentially have there like one one is two. So I mean, one device is phone, one device is computer. Like it can change for that, so it can affect it. Okay. Let's say my computer sends a message to the Google server 30 milliseconds later. Google received that message 40 milliseconds later. My computer gets an acknowledgement, acknowledgement from Google that it received the message. That's total round trip latency of 70 milliseconds. So total is that, okay? The latency depends on a number of physical factors. The type of connection from my computer to Google, the distance from my computer to the Google servers, and the congestion in the network, which may mean my request has to wait in line. Yeah, it's waiting there. There is a major limiting factor, the latency. The speed of light, nothing can move faster than light, not even our very important internet request. The speed of the light is 1 foot, what is that? 1 foot per nanosecond, right? Which means a trip length of at least 30 milliseconds from Los Angeles to Tokyo. Wow. We can't do much about the speed of light, but we can decrease latency by reducing congestion and improving our physical connections. We'll speak about this too. Yeah, let's speak about internet speed. So, which factor will affect it? Our internet speed. We have we have normal cable, we have radio signal speed, and we have the light diversity, right? We'll check all. Internet speed. Speed is a combination of bandwidth and latency. Okay? Computers split up messages into packets, and they can't send another message until the first package is received. Even if a computer is on a connection with high bandwidth, its speed of sending and receiving messages will still be limited by the latency of the connection. You can measure the current speed of a network using an internet speed test, a website that downloads and uploads data while tracking how quickly the data is transferred. Here are the results from an internet speed test from my home laptop. So this is from Khan Academy, so you can know it, you can understand. Ping is the ping is the here like delay, okay? Like in 18 milliseconds it's going and coming, so the information coming from the places, I don't know which place, and we downloading from another server is just taking information, and uploading is the fast than download, because download is just you bringing information from another place to in your computer or in your phone or in somewhere, okay? But upload is faster than download because it's already there. It's just you just opening in your computer. Okay. Anyway, it is 39.09 megabit per second, which is we can talk about um how many million bits. Okay, it's like 39,000 kilobits per second. 39 will be 3. Yeah, many more information will be there. You can just speak later, and this one upload will be at the same time. This, okay. Let's come here. The latency, also called the ping rate, was just 8 milliseconds. That's fast enough for most multiplayer online games. The download bit rate is 39 megabits per second, and the upload bit rate is 5.84 megabit per second, significantly less. Actually, that's expected. Internet providers often support a much faster download speed than upload speed, because internet users spend much more time downloading data, reading articles, watching movies, than uploading data, writing blog posts, submitting forms. Yeah, it's all. Let's come here. Some question have for check our understanding. Check your understanding. Computer networks. First, we will talk about it. So practice questions. The following illustration represents a computer network. Let's check. Here we have data center or server, you can think like that. We have laptop, we have phone, we have again laptop and tablet or something like that. Anyway, let's come here. They are connecting to each other. What is indicated by the lines between the competing devices in this illustration? The competing devices are plugged into the same power source. Now, the competing devices are able to send messages to each other. The competing devices are all running in the same program. The competing devices have access to central database for storing program data. What do you think? Which one will be true answer? Yeah, the answer here is the C, I think. Okay, the competing devices are all running the same program. Yeah, because we have. Uh, it's this one. Yeah, it's all working here. But I will check it if you want. So, it's the C. Maybe, like, yeah, I see new this question. Let's come down and here let's look. We have which of these situations describe the creation of a computer network? A photographer organizes thousands of photographs and videos on their computer's hard drive. They create a hierarchical structure of folders with child folders and as many levels. It's not that. A programmer develops an interactive poster to help their babe learn the alphabet. The poster displays to each other to the alphabet with a push button underneath. The push buttons are input devices in Arduino microcomputer. When the Arduino detects a push, it randomly picks a word starting with that letter and send audio file and some crazy things. Anyway, look others. A software developer set up a multi-monitor setup in their office. Their desktop computer is close to three monitors that are arranged horizontally across its desk. One monitor shows their browser, shows their code editor, and shows their terminal. Anyway, so this is not that also. A college campus creates multiple computer labs, different part of the campus, and connects labs to each other with underground fiber optic cables. This is the transfer because it's saying fiber optic cables. It's connecting to each other, and it's what's saying students can save their file on a computer in a one lab to still access their phone. Yeah, well, let's come down. What is another question? Oh, here. Three. Which of this configuration does not represent the computer networks of six devices? Oh, let's check it. The blue rectangles indicate devices, and the green lines indicate the greens have to think like that. Okay, greens is just that. Indicate the communication path between the devices. Okay, now just think which one is which one is just not represent six devices. This is connected to each other like that. Let's look down. It is different. Yeah, this one there is no have some connection. So for that we can say this place is not true because there is no have connection. Yeah, this one. Let's come the bit rate and bandwidth, another topic and practice questions. First question is in 2015, the nation of Burundi had an average bandwidth per internet connection is like 11.24 kilobit per second, which is like 11,240 bits. In 2016, their average bandwidth was, oh, it's decreasing at 6.991. Which statement is true based on those statistics? Okay, let's go a little right to the here. Okay, which statement? Um, let's say internet connections in Burundi in 2015 had to wait longer for data to arrive than connection. No, it's not that. Internet connections in Burundi in 2006 had to wait longer for packages to arrive. Uh, Internet connections in Burundi in 2015 were able to transfer more bits per second than Burundi's 6. Internet connections Burundi in 2016 were able to transfer more bits per second than connection. No, this one is true. Sending more in 2015 is sending more information than 2006. A new high school is built and needs to be connected to the internet. The IT administrator found this for local providers for internet devices. Okay. Provider BuildNet Spectral Web Final Link and TopSat, which is bandwidth is 100 megabit per second, 50,000 and 25. Which of these comparisons between the providers is correct? TopSat can transfer 4 times TopSat, which is this one, per second than BuildNet. No, it's not true. It's not possible. BuildNet can transfer 5 times more data per second than Spectral Web. Let's look. BuildNet Spectral Web. No, it's not true. Spectral web can transfer 2 times more data per second than for TopSat. TopSat is just there. Spectral web 2 times. Yeah, this one is. Look, another question. Finally, can transfer 100 times more data per second. No, I think spectral web can transfer 2 times more data per second for TopSat. Yeah, yeah. This one is true. Yeah, this one. Let's come down. Another will be what? This is second question and third question. Okay. Josiah used the tool to measure how many bits he could transfer over his home connection to the internet. This table shows the bits transferred each second. Second and bits transferred. We're looking here. Okay. Let's come down, guys, and look here. According to those measurements, what is the bandwidth of the connection? Okay, this is 1,100 bits. This one is just not that. Okay, this one is just 800. Okay. Anyway, let's take pencil. I'll take my pencil here. This one is the bandwidth. Yeah, here. Crazy thing happening. Just stop. Oh, right here and here. Okay, this one is true. Yes, guys, it's all really all is that. This one is true. 1,100 bits is the rate. Another topic. We'll talk another topic later about addressing the internet. We will start to understand IP addresses and all this stuff again. Thank you so much for joining. Next lecture will be about addressing the internet. So we'll start with the IP addresses, and again we'll do some practice questions and more and more. Thank you so much for joining. Have a good time there. Thank you. I appreciate you. You are here. Bye bye.